Hello, and welcome to Statistics One Sample Proportions Lecture 2. So we discussed confidence intervals last time, and now we are going to move into hypothesis testing. So hypothesis testing is a stronger version, all right, of inference. Confidence intervals are good, all right, but hypothesis testing is more about lending a larger amount of support versus just estimating. So we want to think, all right, about the logic of jury trials. We start, right, with the assumption the defendant is innocent, and then we try and prove, right, beyond a reasonable doubt, all right? And at that point, that's when you say guilty, all right, or not guilty for the verdicts, right? Lend evidence, and evidence is supported and presented based on the the hypotheses that were initially created. The statistical twist here is that instead of beyond a reasonable doubt, we actually have a p-value, and p-value stands for probability value. This actually allows us to have a number associated to the chance, right, that the defendant did not commit the crime given all the evidence. So we actually know that value. So it doesn't have to be beyond a reasonable doubt, because ideally beyond a reasonable doubt is almost a 0%. That's the idea. For our wording, we say reject the null hypothesis and fail to reject the null hypothesis. This matches our wording of a jury trial, which is guilty and not guilty, right? Be aware that the wording of a jury trial is not guilty and innocent. It is guilty and not guilty. So we have that same wording here. Reject the null hypothesis. That's our guilty verdict. And fail to reject the null hypothesis. That's our not guilty verdict. So the hypotheses we are going to create, all right, we denote them HO and HA, the null hypothesis and the alternative hypothesis. For our jury trial example, right, the null hypothesis states the defendant is innocent. And now be aware, that actually is the hypothesis, okay? That's not the decision made when we say guilty, not guilty. The alternative hypothesis is the defendant is guilty, right? There's only actually two truths that exist. The defendant is innocent or the defendant is guilty. So the whole idea, right? We move through it like a court trial, assuming the defendant is innocent. We collect data, that is, collect evidence. All right. And then we ultimately make a decision. And in stats, we actually can identify the kind of levels that we determine, right? Is there a 1 in 20 chance that they didn't commit the crime, or a 1 in 100 chance? What is our definition, our judgment of reasonable doubt? So again, it's going to mirror the concept of a jury trial, but the actual steps, all right, have their own statistical scientific twist on them. So, like I said, null hypothesis, which we denote as HO. In the science part, that's the parameter equals a value. Our first parameter that we're going to be investigating is P, the true proportion. All right, but we're going to see other ones as we move through our material. And then the alternative hypothesis. So this initially starts out as the parameter is less than, greater than, or the new one not equal to the value. So this parameter not equal to the value means it's just as likely for something to be above as it is below. So that's the new one, and this is what's known as a two-tailed test. So it's just as likely to be on either extreme. The other ones are one-sided tests, and these are the ones we're much more familiar with, right? It's going to be below this number, right? Which means we shade to the left. If we say it's going to be above this number, then we shade to the right. So that's definitely what we are most familiar with, right? As we saw previously in previous normal calculations. So let's look at an example. We want to see if people prefer Coke or Pepsi. A random sample of 550 people was taken and found 284 preferred Pepsi. It is reasonable to believe that half the country likes Coke and half likes Pepsi. We will let P represent the proportion of people that like Pepsi. So start off, as always, let's identify information. P is the true proportion. P hat is the sample proportion. N is the sample size. And now we have a new one, P0. This is the assumed proportion. The assumed proportion or the hypothesized proportion, all right? Anything to that nature. The guess proportion, the claimed proportion, that's the one that is the initial assumption of the defendant is innocent. All right. So the true proportion, just like before, we don't know what that number is. All right. We never know. That's what we're doing the inferences on. The sample proportion, that is collected directly out of the data. 284 people prefer Pepsi out of 554 people. The assumed proportion then, all right, is the believed value, right? So in this case, it is reasonable to believe half likes Coke, half likes Pepsi. Well, half, that means 50%. And then the sample size, 550. So the null hypothesis, P equals 0.50. The true proportion is equal to the assumed proportion. The alternative then, the true proportion, something about the assumed proportion. Like we previously viewed, there are three options here: greater than, less than, or not equal to. And this will be indicated in the problem, okay? You don't base this off of the data. This is something we are trying to prove in the problem, all right? Notice it doesn't say greater than, it doesn't say less than, which means if there is a lack of indication, well, I'm not sure which way it favors. Does it favor Coke or does it favor Pepsi? So that means I want to prove a not equal to alternative hypothesis. The module is going to be normality, right? So normality is is going to be our big focus. All right, that's our standard underlying assumption. So we need to identify if we have a normal model. Our conditions are going to be very, very similar to what we saw before. We still have the large enough condition. N equals 550, greater than or equal to 40. That is satisfied. Then the success failure conditions. N, P, 0 now. It's not P hat, okay? Because it's all about the assumption, all right? Right? The defendant is innocent is our initial assumption. So in this case, we assume that our claimed value that half the country likes Pepsi is the true value, and we will have strong evidence to disprove that. That's our goal, okay? We are the prosecutors. We are always trying to prove guilty. So, but we start with their assumption. 550.5, 275 greater than or equal to 10. That is satisfied. And Q0, it's the same because 1 minus 0.5 is still 0.5. 275 greater than or equal to 10. That is satisfied. All right, all conditions are met. So we can assume the sampling distribution of p hat is normal. Remember, any of those individual conditions fail, it all fails. So the one proportion z-test, which again still has our general form. Observation minus the mean divided by the standard deviation. This is our standard z-score equation. But we are going to use StatCrunch to do the calculation, so I'll demonstrate it once, and then we'll never do it by hand again. The probability that we are going to find, we now call that the p-value. So let's find the p-value. Z equals the observation minus the mean divided by the standard deviation. Our observation, and actually let's draw a picture while we're at it. The mean is our assumed value. Our observation, that is the observed proportion, is our 51.6%. Our picture, and this is the big thing, because our alternative hypothesis is a not equal to, our picture is shaded on both sides, which means that we first need to find this top shaded area. Then in order to find the bottom shaded area, since this is the normal model and it is unimodal symmetric, all right, all we have to do is multiply that value by 2. So let's start with our calculation here. And the standard deviation is P0 Q0 divided by n square root the whole thing. Calculate away gets our z value of 0.77. We then are going to look that number up in our z table. And 0.77 is right here. Gets us 7794. Now be aware, that was a left area. So what we actually just found was the area to the left, all right, of 0.516, which means we need to 1 minus in order to find the area to the right. And, all right, which is about 22%. So this guy is 2206, which means this one is 2206 as well. And so the fast way to do that is to then also multiply it by 2, giving our p-value of 4412. That's how we could do it by hand. Just to verify, let's do this in StatCrunch. Proportion stats, one sample with summary. So number of successes, 284 out of 550 observations. We are doing a hypothesis test, and it is about 0.5, not equal to. So now we're right. It says perform hypothesis test for P. I'm going to hit compute. And notice, all right, the Z-stat is 77675, and their p-value, right, 4428. Now, ours was 4412. That's because, notice, they're doing a more precise calculation. We rounded our Z-stat value to 77 to look it up in our table. All right, so it has the exact value. 4428, 4412 doesn't actually change the calculation. All right, but just be aware they are slightly different. And doesn't change our conclusions either. So the big part, all right, is the interpretation. Again, no more probability statements, anything like that. But now we have conclusions, and we have three big parts to the conclusion. First is the decision. That is our verdict. All right, so we have to read the verdict, guilty, not guilty. Then, all right, we're going to talk about the evidence. Basically, that's the reading of the charges. And then lastly, interpretation of the p-value, and that's basically the discussion of reasonable doubt. Because our p-value, that's what it represents. So let's state our conclusions. The first is the guilty, not guilty verdict. So we're going to talk more about how to make this decision, but the basic concept is, all right, the rule of thumb if P is low, the HO must go. We're going to talk about the details, but that's the easiest thing to recall. Low, and just so you know, low is like below 10%, right? 1 in 10 chance or less, that's low. This 44%, that's kind of close to 50%, that's 1 in 2. 1 in 2 is not low. If something happens half the time, that's happening a lot. And so that's the big thing. The discussion of what is low, people struggle with. But remember that this is all on a percentage scale, 0 to 100%. So when you think 0 to 100%, what is low? Low is usually something that happens less than 10% of the time. So in this case, right, P is not low. That means the HO is not going to go. All right, that means this is common. This is commonly occurring. If something is commonly occurring, that means the defendant did not commit the crime, right? Because the interpretation of the p-value is basically this. There's a 44% chance, assuming the defendant is actually innocent, given all the evidence collected, that they did not commit the crime. That means there's a 56% chance they did commit the crime. That's not very high, okay? In order to give a guilty verdict, you want to assume there is a high chance the defendant did commit the crime, right? Or that is a low chance the defendant did not commit the crime. So, all right, we're gonna talk more about that in just a little bit. So I'm going to say not guilty, fail to reject HO at any reasonable significance level. And we're going to talk more about that as well. All right. And this was a not guilty verdict. Then the reading of the charges. So if you said not guilty, all right, then you basically need to talk about the evidence. Was there a lot of evidence or not enough evidence? Well, if we said not guilty, there was not enough evidence to convict. And that's basically what we're going to read here. there is weak, all right, and there is insufficient, not enough, or weak. I like to say weak and strong. Weak evidence. There is weak evidence to show that. Now the reading of the charges. The charge is the alternative hypothesis. This is the charge. So basically, I'm going to say this in words. What does P not equal to 0.5 mean in context? All right, there's weak evidence to show that the true proportion of people who prefer Pepsi differs from 50%. And that's it. It is that simple. I'm literally just interpreting HA in words here. All right, last and definitely not least is the p-value interpretation. All right, and this one I'm going to break down into both in context and the pieces involved. Okay, so there is a 44.12% chance that we would randomly observe 284 people who prefer Pepsi out of 550 people, assuming the true proportion of people who prefer Pepsi and Coke was actually split evenly at 50% to 50%. Okay. There are three big pieces within this. All right. And I'm going to identify them because this is the court, the jury association, and then the stat interpretation. So this first piece, all right, first piece, second piece, and third piece. So there is a 44.12% chance that we would randomly observe. That right there, that's literally saying reasonable doubt. And basically, that's what a p-value is, right? That's the actual discussion of the p-value. Then 284 people who prefer Pepsi out of 550 people. That's the evidence. AKA the data, right? The statistical part, It's not, we're collecting the bloody clothes. It's the data that we collected. And then the last part is saying, assuming the defendant was truly innocent. Because all of this interpretation is based on the assumption the defendant is innocent. That is, it's based on the assumption, assuming HO is true, the null hypothesis. That's why if we're able to say guilty, if we're able to say reject HO, it's because we had lots of evidence against, all right, the null hypothesis. So we had so much evidence, all right, that it is impossible, right, for the null hypothesis to be true, right? There was so much evidence collected, all right, that it was impossible for the defendant to actually be innocent. That is the p-value interpretation. Now, I'm going to do this interpretation multiple times and in different orders for various problems as we proceed through the material. It doesn't have to be in the same order, so it can be in a different order, all right, as long as you have the three pieces, all right? Reasonable doubt, the evidence, and then assuming the defendant is innocent. All right, so backing up now, how to make the actual decision. So you got to start with the correct verdict, right? Guilty, not guilty. Now, the general rule of thumb, like I said, was if P is low, then the HO must go. The official rule is this. If the p-value is below alpha, reject HO. If the p-value is greater than or equal to alpha, fail to reject HO. Alpha, also referred to as the significance level. The significance level is what is your definition of rare? Now, good news, in statistics, we only have a few definitions. 1%, 5%, and 10% are the most common definitions of what is rare. Something happening 1 in 10 times, 1 in 20 times, 1 in 100, right? Has to be around that neighborhood. And that's what I was talking about. 10% or below is what we consider low. Now, if the significance level is not specified, I recommend, all right, the convention is to use 5%, right? Unless otherwise stated. So basically, I was like, because that's the most common convention. Something happening 1 in 20 times or less, that's what we consider to be rare. 5% is what status that number is what all hypothesis testing has to be satisfied at for a statistician to testify in court. All right, legally, that's actually the number. All right, for all data to be used with any significance, 5% is the number. So this is the rule, and you can use that rule to make your decision. I always just like to think P is low, the HO must go. But all right, initially, in order to make sure you're making the correct decision, that's the best approach that I can recommend for you. So just to make sure we understand the rule, I want to suppose that after performing a hypothesis test, I get a p-value of 0.03. What would our decision be at the 1%, 5%, and 10% levels? So the p-value is 0.03 and alpha is 0.01. So again, just using the rule right here, I see the p-value is greater than or equal to, right? 3% is greater than or equal to 1%, which means I fail to reject HO, all right, at a 1% significance level. A couple of notes. So FTR, fail to reject. Okay, that's shorthand there. be aware that there is no note. Don't use RHO, right? Reject HO. That one, write out reject HO, but FTR, that is pretty common notation, all right, for shorthand. Again, just to verify, let's do that again. P-value is still 3%, but now my significance level is 5%. Now in this case, notice 3% is less than 5%, which leads us to the conclusion, reject. All right, seeing the rule up here, I'm going to reject HO at a 5% significance level. And lastly, let's do that one last time. P-value is still 3%. Now my significance level is 10%. And 3% is less than 10%, which tells us that we are going to reject HO at a 10% significance level. And notice that if I keep increasing these 20%, 30%, 40%, I would continue to reject. Once you can see the cusp value, which is a significance level 3%. All right. From there on, as the significance levels increase, you continue to reject from then on. But this rule, all right, can be very, very helpful to initially, because again, you've got to make sure that you have the correct initial verdict. All right. If you don't have the right initial decision, all right, the rest of your conclusions can be messed up very easily. Let's look at another example of start to finish all the way through. In some states, the law requires drivers to turn on their headlights when driving in the rain. A highway patrol officer believes that less than 1/4 of all drivers follow this rule. As a test, he randomly samples 200 cars driving in the rain and counts the number whose headlights are turned on. He finds this number to be 41 cars. Does the officer have enough evidence at the 10% significance level to support his claim? So first, foremost, let's identify information. P hat, P0, N, and significance level, alpha. So true proportion, unknown, sample proportion. Right? We see that's the sample, 41 out of 200. The sample portion, by definition, comes out of the sample. The assumed proportion. All right. Notice, right? This is a claim, a belief, a hypothesized value. The officer believes, all right, 1/4. 1/4 is 25%. And the sample size, 200. And now notice, the significance level here was actually specified. Often it is not. But be aware, this won't be subtle. The only way to say significance level is either significance level, alpha, or alpha level. So it's very explicit. In this case, 10%. So this one, we actually were given one. If it was not given, use 5%. That's the convention, all right? And that's the one that you should use if it's not specified. All right. Information is identified. Let's set up our hypotheses. HOP equals, all right, the assumed proportion, 0.25. HAP and 0.25. And this, again, usually this is indicated in the problem. Do not base this on the numbers, on the data. But this says less than 1/4, right? We want to show, right, is there enough evidence, all right, to support his claim, right? Can you support that it's below 25%? Now, Note the hypotheses here. It says P equals 0.25 and P less than 0.25. That is typically how we write hypotheses, and that's how StatCrunch and almost every software out there presents hypotheses. But technically, there is a hidden null hypothesis that actually says this. P greater than or equal to 0.25, because this has to cover all the values from 0 to 1, right? P less than 0.25 covers 0 to 0.25. Then it can't just be 0.25. It has to be 0.25 to 1. Because if you find the value to be 0.99, well, that's not included in your hypotheses, which is why this, all right, this hypothesis is what the null actually says. And I bring that up because that's going to be important in our interpretation. And I bring that up because you have to understand what your hypotheses actually say. StatCrunch and almost, like I said, every software out there does not indicate what the actual hypotheses are. Okay, let's check our conditions. Large enough. N equals 200, greater than or equal to 40. That one is met. Success failure. NP0, 200 times 0.25, which is 50, greater than or equal to 10. Check. NQ0, 0.75, which is 150, greater than or equal to 10. Met. All conditions are met. So we can assume the sampling distribution, all right, of P hat is normal. All right, so calculation, observation minus the mean divided by standard deviation. Again, I don't run through the calculation. StatCrunch is going to handle it. It's going to give me the Z value and the P value that we need, all right, for interpretation. But what we do want to understand is what the picture looks like. So the mean, which is the assumed value, which is 0.25, and then our observed value, which was 0.205, right? And the picture is shaded based on the alternative hypothesis. The alternative hypothesis is a less than, which means we shade this picture to the left. And that's the part we want to make sure we understand how pictures are shaded, because, right, that's going to be important in later and with our interpretation. We need to make sure we understand what's happening. All right, so to StatCrunch, once again, notice we keep going into proportion, one sample with summary. We've had a lot of summary information because the data, what the data actually looks like, would just be a big list of, zeros and ones or trues and falses, yes, nos. All right, it's literally a list of successes and failures. But just be aware that's what it will look like. All right, so in this case, 41 out of 200. We're doing a hypothesis test. Change that to 0.25 and less than. Every time before I go to StatCrunch, I see the mistake that people rush to StatCrunch. Write stuff down, identify your information, write everything out that you possibly can before you go running into StatCrunch, because that's the big problem for sure. Then I hit compute, And notice, here's my z-stat and here's my p-value. Negative 1.47 and 0708. So no hand calculation required. That allows us to go directly to the conclusions. And now this isn't an official step, but a lot of people initially this is helpful. If just writing out the rule, p-values less than alpha, then reject HO. Now, again, that's not an actual step, but our first step is to do our verdict, right? Our decision. Guilty, not guilty, reject HO, fail to reject HO. Put in your values here if you're struggling. So 0.0708 and alpha 0.10. 7 is less than 10, which means that I am going to reject HO. Now, here's the other big thing. Always state your significance level. We saw above different decisions result in different significance levels result in different decisions, right? Fail to reject at 1%, reject at 5%. So that's why we always state our significance level. Reject HO at a 10% significance level. If we were doing a 5% here, we would have failed to reject. So it's important to understand, all right, what significance level results in what decision. All right, then the reading of the charges. I rejected HO. That is, I said guilty. That's my guilty verdict. So there was sufficient, enough, all right, or as I like to do it, there is strong evidence. There is strong evidence to show that the true proportion of cars that drive with their headlights on in the rain is less than 25%. Again, simply just the alternative hypothesis in words, right? That's all this is. HA in words. And then again, last and definitely not least, p-value interpretation. All right, so assuming the true proportion of cars that drive with their headlights on in the rain is actually 25% or more. Now, this is about the null hypothesis, so this is why I was emphasizing 20, this is 0.25 greater than or equal to. That means 25% or more, right? That's what the null hypothesis actually says. And that's important in your interpretation as well. There is a 7.08% chance, right, that we randomly observe that we would randomly. All right, we would randomly observe 41 cars with their headlights on in the rain out of 200 cars, right? Reasonable doubt and the evidence. So, p-value interpretation. All right, make sure you have all the pieces. And the big one, without a doubt, is that 25% or more. That's the biggest one I see that people struggle to understand because you have to it doesn't state that. It doesn't state it in StatCrunch, doesn't state it in almost any technology. All right, it always just says equals 0.25. So you have to understand the hidden hypothesis that is actually there. All right, one more little example. And this one is really, really interesting because how much info we have and don't have. The seller of a loaded die claims it will favor the outcome 6. We don't believe that claim and roll the die 200 times to test an appropriate hypothesis. Our p-value turns out to be 0.03. State the hypotheses and then choose an appropriate conclusion. So, as usual, let's go and identify our information. Okay, so sample size 200. The true proportion P is unknown. All right, notice I have p-value of 0.03 here. So that's different, unusual information because typically we don't have the p-value from the get-go. Now here's the other big part. Notice here. All right, p0. P hat and p0. I don't really see any other direct information, right? There's no, oh, I collected this many out of this many values. So that part, all right, we need to make sure that I was like, I don't have a sample proportion. I clearly don't see one. But be aware, we only ever have the sample proportion to get the p-value. So I don't have it, but I also don't need it. Now I would need it to make a better interpretation for my p-value interpretation, but I'm going to assume we're not going to do that here. P0. Now notice, again, there are no other numbers. So, but we're talking about a die. Well, and a 6. So you just have to understand, well, what's rolling, getting a 6 on a die, a standard 6-sided die, that should be 1 and 6. So even though the numbers aren't explicitly stated, they're inherently given. And that's what I like about this problem. So state our hypotheses. Right? HO, P equals 1/6. HA, something about 1/6. So now let's see. The seller claims it will favor the outcome 6. We don't believe that claim, all right? And we want to test the hypothesis. So that means if someone says the die is favored and you say you don't believe it, well, that means you're starting with the basic assumption the die is fair, as most die are. And then you want to prove, right, that the die favors the outcome 6. Well, favoring the outcome 6 means it would roll 6 more often. So it would have a greater than 1/6 probability. Right? So we're starting with the assumption the die is fair. And we're trying to prove the die is loaded, right? AKA favoring the outcome 6. So notice that with very little information given, I can set up hypotheses, and actually I know a lot going on, even though a lot wasn't told to us. Then I could choose appropriate conclusion. All right, so notice, all right, I have a p-value of 0.03, right? That's low. So hence I would reject HO, right? And then I would claim, right, that it appears the die is loaded. So based on that, so let's see which one of these matches that. There's a 3% chance that the die is fair. Yeah, definitely not that one. There's a 97% chance the die is fair. Okay, that's the wrong number. There's a 3% chance that a fair die, okay, so right, that was our assumption. We assume the die is fair, all right, could randomly produce the results we observe, so conclude the die is loaded. Oh, that one looks good. There's a 3% chance that a loaded die, oh, that's already wrong because we assumed, right, this is what we assumed, right, assumed to be true. And then this is what we want to prove. All right. And in this case, actually did prove after the p-value. But when you write your hypotheses, that's how you want to think about it. What you assume to be true and then what you want to prove, right? Remember, you are the prosecutor. And so clearly that's the conclusion. And that's why I like this problem. Look, no calculation, all right, was required here. This was purely just thought, all right? Identify information and then apply it to a correct answer. As a note, hypothesis testing, widely used, widely misused. We're going to look at this next time, see what goes wrong. Don't base your hypotheses on the data, base it on the question. And then conditions. Conditions are going to be everything for us. All right, that should be everything. Have yourself a wonderful day.